Yeah, so hello, welcome. My name is Peter Muller. I'm from Kontron, and I would like to give you a brief overview, brief introduction on how Kontron and Micron are cooperating, or more how Kontron is using the memory chips and flashes from Micron in our industrial modules and boards. And especially I also will talk a bit about which markets we are targeting with that, and where we see the benefit of Micron's flashes and memories here. Yeah, what we are as Kontron especially see as needs for the new markets in embedded industries. So as I show here, it's I think you've often heard it's 5G and AI as new upcoming markets, where you have usage in autonomous vehicles, but also servers in a factory floor. And this is all use conditions where you have where you can't work with commercial chips in general, or commercial boards in general, like standard motherboards. And this is what we are addressing as Kontron with our computer or modules. So what is the technologies we are looking here is as shown here under technology evolution. DDR5 memory for sure, that's where we mainly will dig into with the next slides. But it's also other aspects like PCIe Gen 4, also Gen 5. It's also 100 gigabit Ethernet, so high-speed Ethernet connections, also in a very broad extent. It's USB 4, and for sure also manageability, which is important. So what Kontron is offering, or where we are using the Micron chips? This is a little kind of a dense roadmap what we can offer on our modules portfolio. So what you see here is kind of showing the different performance levels also, which is kind of in combination with the power. So we have very small system or modules which are directly soldered on the boards, and which are also carrying the memory on this module, on these tiny modules. Then you have the slightly bigger module standards like Q7 and SMART. You probably already heard about. So this is kind of module standards. Also other competitors of Kontron are offering. And also on these platforms we have the CPU and memory soldered down. So it's a complete computer, and you leverage the needs of your interfaces, like the connectors or the other IP you have on a carrier. So you have a connector, and with this connector all needed interfaces like PCIe, like SATA, like USB, whatever goes down to the carrier, and there you can do the infrastructure for your system or your application. So this is the very low end, and then with COM Express, what you see here, and the new COM HPC concept, which we will look into later, is from a performance perspective really more addressing these 5G or AI applications then. So coming to COM HPC more in detail, and this is these platforms or modules where we really already distribute our DDR5 use here for the Micron platforms. So you have the COM Express. This is the upper one. This is this design here. So you see this is soldered down LPDDR5 memory on this module. Again, including a complete concept of a computer system. With this board, for example, you have up to 14 cores. You have, as I just said, up to 64 gigabyte of LPDDR5 memory, which we can support here. And you also have a higher speed Ethernet, 2.5 gigabit. Not this full speed of 100 gigabit. This is more for COM HPC then, where we can leverage this. HPC concepts I mentioned here for especially these high-end HPC solutions. So here you see we have SODIMM sockets where we can carry the Micron DDR5 memory sockets or modules. The difference between these two is the one you have a soldered CPU, and on this design you have a socketed CPU. So this is kind of new for the modules environment. So up to now most module standards only were supporting soldered CPUs. With this concept now we also have the possibility of socketed CPU support. So this gives us the opportunity to really get into even higher performance level with a module. So up to now you've only seen that for standard motherboards where you have socketed CPUs, and with this new HPC standard you also will see socketed modules which are really as used for high-end applications like servers. In a kind of a summary here, what I'm talking about. So what do we want to reach with this LPDDR5 memory on our modules? So the idea of a module concept, of a module application always is to have as less power dissipation as possible. And so for sure here LPDDR5 has an improvement against former technologies like DDR4 or DDR3. So this is one important aspect we see here. For sure the other aspect also is, as I said, we need highest performance as possible. So also from the memory side we need the best data transmission, or bandwidth, bandwidth and density. Why do we need this? So what's the applications? I mentioned it on the first slide already. It's faster processing and higher memory intensive applications, so like 5G use or especially AI use. You know you have a lot of cameras catching data and you have to process all these data. So for sure this is intensive memory use, and for that DDR5 has some improvements against the former technologies. And for sure, especially in our industrial environment, we mainly are targeting with these platforms. Also the ECC use is of importance, or especially on-die ECC use is of importance. And this is also what we can get here with these new DDR5 technologies. So this is in very brief kind of a summary what Kontron is doing on or with DDR5 memory on our modules. Besides the memory itself, it's also interesting probably, we are also using NVMe flashes on our modules. So also the Micron NVMe is in use here on all these modules I've shown on the roadmap. So there really is a very broad cooperation here on that level of implementation for flash and memory on the boards.